La constelación del Lacerta es un modesto puente entre mitos y misterios de Vía Láctea.
El corazón de un blazar reside aquí. Un agujero negro que emite rayos de energía.
Johannes Hevelius notó con ironía que en este lugar solo cabía una pequeña lagartija.
El mito de la transformación de un joven nos recuerda la modestia ante la eternidad.
You know, when we look up at the night sky, some constellations are just obvious. They demand our attention. But today, we're going to turn our gaze to one that's a bit more subtle, Lacerta, the lizard. And we're going to explore why this unassuming little patch of stars is actually one of the most scientifically crucial regions in the entire northern sky. And it seems only right to start with the words of the man who put it on the map, Johannes Hevelius. Back in 1690, he wryly observed that this part of the celestial sphere was so packed with mythological giants and heroes that, well, nothing larger than a lizard could fit there. It's a sentiment that perfectly captures the compact, almost overlooked nature of this constellation. And that quote really gets to the heart of our thesis today. You see, unlike the grand, sprawling figures of antiquity, Lacerta isn't rooted in some ancient myth. It's a product of the modern scientific age, a triumph of precision, really, designed simply to fill a gap on the celestial map. So here's our roadmap. We'll start with the fundamentals, its position and visibility. Then we'll dive into the truly incredible astrophysical objects it contains. From there, we'll look at its modern origin story, touch on an ancient myth that has become associated with it, and then finally, we'll talk about how you can find it for yourself. Okay, first things first. Before we can appreciate what's in Lacerta, we need to define its place in the cosmos. Let's establish its basic physical parameters and, just as importantly, who on Earth can actually see it. This table really quantifies what we mean by modest. Out of all 88 officially recognized constellations, Lacerta ranks way down at 68th in terms of size. It covers just a sliver of the sky. And even on a perfectly clear dark night, you'd be lucky to spot maybe 60 or so of its stars with the naked eye. It's faint. But here's the good news. Despite its faintness, it's incredibly accessible to a huge portion of the world's population. As you can see, it's a true fixture of the northern hemisphere sky. And for those of you at higher northern latitudes, say in Canada or northern Europe, it's actually circumpolar, meaning it never sets. It just circles the North Star all year long. All right, now for the main event. Let's look past its faint exterior and see what's hiding within Lacerta's unassuming boundaries. Because frankly, despite its small size, this is where its true scientific significance just explodes into view. Now, its brightest star, Alpha Lacertae, isn't going to win any awards. As you can see from this comparison, it's a pretty standard main sequence white star, about twice as massive as our sun and a little over 100 light-years away. It's the brightest point in the faint zigzag that gives the lizard its shape, but it's not the main attraction. This is where the story of Lacerta takes a radical turn. There's an object in it called BL Lacertae, and it caused a complete revolution in our understanding of the universe. As this timeline shows, for decades we thought it was just some uninteresting variable star, right here in our own galaxy. But in 1968, astronomers realized it was something far, far more extreme. And in doing so, they discovered an entirely new class of cosmic object. So what in the world is a blazar? Well, you take a supermassive black hole at the center of a very distant galaxy. As it furiously consumes matter, it blasts out these enormous jets of particles at nearly the speed of light. Now, what makes it a blazar is that by pure cosmic chance, one of those jets is pointed almost directly at us. We are, quite literally, staring right down the barrel of a cosmic particle accelerator. 900 million light-years. Let that number sink in. That's how long the light from BL Lacertae has been traveling through space to reach our telescopes. This isn't a star, remember. This is the intensely bright, active core of an entire galaxy. The light we see from it tonight began its journey when the most complex life on Earth was just starting to evolve in the oceans. And as if a universe-altering blazar wasn't enough, Lacerta also hosts a fascinating puzzle for planetary scientists. The exoplanet HAT P1 is what we call a hot Jupiter, but with a twist. It has about half the mass of our Jupiter, but it's so incredibly puffed up and bloated that its overall density is about the same as a piece of cork. It's an anomaly that continues to challenge our models of how planets are supposed to form. Now, for all you backyard astronomers, here's a real treat.
Lacerta contains a beautiful open star cluster, NGC 7243. With just a simple pair of binoculars, it resolves into this faint, hazy patch. What you're actually seeing is a young family of dozens of hot, brilliant blue stars, all born from the same stellar nursery and still loosely bound by gravity.
So, we've analyzed the astrophysics. Now let's turn to the human element, the story of how this constellation was actually created and the clever bit of wordplay hidden right there in its original name. This timeline reveals a quiet little celestial turf war. Hevelius's simple scientific name, Lacerta, ultimately won out over these much grander, politically motivated attempts to flatter European kings. You can see both French and German astronomers tried to dedicate this patch of sky to their monarchs, but in the end, the simple lizard endured. And here's the best part. Hevelius's choice was deliberately clever. He didn't just pick any random lizard. He named it for the Stelio lizard, a type of agama common in the Mediterranean. And as you can see, the name itself is a fantastic little pun on the Latin word stella, which means star. Hevelius literally placed a star lizard in his star atlas. Now, because it's a modern constellation, Lacerta doesn't have an official ancient myth. It wasn't known to the Greeks or Babylonians. However, its form has led many to connect it retroactively to a very fitting Greco-Roman legend, the tale of Ascálabo. It's a classic story of hubris and divine retribution. The story begins with the goddess of the harvest, Demeter, at her absolute lowest point. She's frantically searching the world for her abducted daughter, Persephone. Exhausted, grieving, and parched, she stops at a small cottage for a drink of water. And it's here that we get the turning point. A moment of pure mortal arrogance. A young boy named Ascálabo sees the goddess drinking so greedily and cruelly mocks her for it. This act of profound disrespect, aimed at a deity in mourning, seals his fate. The punishment is swift and absolute. Enraged, Demeter throws the last of the water in his face, and in an instant, he is transformed into a spotted lizard, a stelio, in fact. He's cursed to scurry among the rocks forever, a permanent reminder of the price of mocking the gods. Okay, let's bring all this history and science back down to Earth. Let's translate this into a practical guide you can use to go outside tonight and actually find Lacerta and its hidden treasures. The trick to finding Lacerta is actually to use its much more famous neighbors as guides. First, find the unmistakable W shape of Cassiopeia. Then, locate the brilliant star Deneb, which marks the tail of Cygnus the Swan. Scan the seemingly empty patch of darkness between those two bright markers, and you'll begin to pick out the faint little zigzag of stars that is Lacerta. With binoculars, your first target should be that beautiful star cluster NGC 7243. But the real challenge, and it's more of an intellectual one, is to find the location of BL Lacertae. Now, it will just look like another faint pinprick of light, but to stand there, knowing you are seeing light from the violent core of a galaxy that's 900 million years old, that's a truly profound experience. In the end, I think Lacerta teaches us a really fundamental lesson about the cosmos. No part of the sky is empty or unimportant. A constellation literally made from the leftover scraps of the sky gave us a whole new class of cosmic object and a new window into the early universe. And it leaves us with this final lingering question. What other great discoveries are out there? Hiding not in the brightest nebulae or grandest galaxies, but in the sky's most modest and overlooked corners.
Gracias, amigos. Aspiren al entendimiento y vuélvanse más sabios.